A pleasant morning to one and all present over here. I, Sneha Shirati from 5th SEM CSE department,
I, Sakshi Naik from 5th SEM CSE department,
are present before you to take you through a knowledgeable journey. The third day first session to be held is on the topic Deep Learning Applications for IoT by Dr. Vani Hiremani, SIT Pune. Now I request Shilpa to introduce our resource person to the gathering.
Good morning to everyone. It's my pleasure to introduce our resource person, Dr. Vani Hiremani. Ma'am has completed PhD from Birla Institute of Technology, Mesra Ranchi, Jharkhand, and MTech from BEC Bagalkot and BA from HIT Nidsosi. Ma'am has total 12 years of teaching experience plus 1 year in IT, and ma'am has associated with Pune Institute of Technology Pune, Amity University Jharkhand, Presidency University Bangalore, and Symbiosis Institute of Technology Pune. Ma'am has published 30 research papers, out of which 2 were SSCI indexed, 12 were Scopus, 1 in WOS, 4 book chapters, and the rest in IGI UGC CATE. Also, ma'am has published patent under Patent Advanced Search System on a system method for developing real-time training dataset for human racial classification. With this brief introduction, I present Dr. Vani Hiremani. Thank you.
Thank you, Shilpa. Now I would like to request Ashwini Gauli ma'am to welcome our resource person, Dr. Vani Hiremani. Thank you, ma'am.
today, to enlighten us about deep learning applications for IoT, we would like to invite Dr. Vani Hiremani from SIT Pune.
Am I audible now? First of all, thank you so much, dear, for providing such a concise introduction of mine. And I'm Dr. Vani Hiremani, and I'm currently associated with Symbiosis Institute of Technology, Lovely Pune campus. Well, very good morning to all the respected faculty members present over here, and research scholars, if any, and dear students. As you're already aware that today we are going to have a session on two most eloquent and influential domains, deep learning and IoT. If you know them individually, then they are yielding a commendable result. But having them together at least is like achieving a par excellence in a different level. So today through this session, we are going to witness that par excellence. But before I could proceed with the session, let me wholeheartedly thank the very respectful Dr. Golgi sir for arranging such a prestigious FDP and accommodating this session of my interest and considering me and giving me an opportunity. Thank you so much, sir. Well, I hope so that majority is student, right? May I have information that how much you are aware about deep learning and IoT? Are you aware, dear students? Little bit? Yes? Okay, fine. So with that understanding, it is better to start, right? Okay. So nowadays, if you could witness that the uncertainty is inflated in many ways, be it heart attacks at young age, fatal road accidents and obstacles, hurdles in the crop yielding due to sudden weather change, flood, drought, and mishaps in the industries. And since from the ages, we have been noticing sudden rise and fall in the share market, isn't it? Uncertainty is there, right? So just imagine that. Isn't it a thoughtful to have a system which could predict, sense the events beforehand of their occurrences and even the consequences to certain level, so that they are bringing in some alert message to the mankind for their preparedness and take precautionary actions and ultimately helping you to be safe. So today through this FDP and through this session, we are going to see the elucidation of that thought, deep learning application for IoT, wherein if you consider IoT, well, what is IoT? Internet of Things. Technically, if I could define IoT, is that it is a domain which is consisting of enormous amount of sensors which are sensing and acquiring massive number of information, and it is regarding the parameters which are falling under an event, so that there is a gigantic amount of information which is fetched out of these parameters through the sensors which are employed in it. Then just imagine this much gigantic information we do have, then who is going to be responsible for systematically analyze it? There comes the intelligent network, deep neural network. This is going to analyze the data which is generated by IoT devices, and it is going to gather the valuable inferences out of it. There has to be meaning, right? If the information is there, then what kind of information it is? So it is just going to gather the inference out of it, which is very much valuable, and it is just making some sense out of that knowledge. So ultimately it is making IoT devices more smarter, right? So that's why it becomes a need of the moment to understand the potential of having the deep learning thing into the IoT applications. So today at least it becomes very crucial to understand that what are the different applications in terms of having the different DL architectures in the IoT field. So we are here, we got a very good opportunity and good platform where we can explore that what are the different architectures present in the DL and how they are going to be used in the IoT. So this session is all about exploring that elucidation, that what are the different architectures, how they are being helpful in IoT to make them smarter. So in line to this, I have constituted some of the points which are going to be a roadmap for this session. So first of all, we are going to start with the introduction, where we are going to briefly understand what is IoT and deep learning to their individual frames. And after that, we are going to see the deep neural network to their brief and its architectures. And after that, we are going to see the amalgamation, the blend of deep learning and IoT, wherein, first of all, I am going to deal with the benefits of having DL in IoT, and after that, I'll be providing some of the reveals where you can see the multiple number of use cases present in the market. And then I'm going to take you deep into a one use case, that is, we are recognizing human activities based upon which we are coming out with some inferences that what that human is up to, right? So I was also part of this case study, so I'll be explaining some architecture and I'll be showing some results to you. Fine. And then we will be wrapping up the session with some discussion followed by question and answers. Fine. Okay. Now, the very first question comes into my mind, that is, what is IoT? Well, IoT is, I already stated that it is a domain which is consisting of enormous amount of sensors which are generating a gigantic amount of information. There are actuators, physical devices and electronic devices which are connected together. They are sharing the information over the network and other means. Initially, I thought of providing some empirical information about IoT, but just providing some of the architecture. But I assume that since from 2 days you have learned much more thing about the IoT. So let's stick to a one video clip, because picture speaks thousand words. Whatever new thing you are going to learn about a new topic, better to visualize it rather than just mugging up the theory part, right? So let's have that video clip, and after that I'll come back to you with a new face of Internet of Technology. Let me see that whether I can play that video. Can you click on introduction, please? Just click on introduction. Yes, sir, the introduction. So this video is all about the current phase of IoT. Just keep this going. It's okay, no worries. Whenever it will be play, then I will come back to it. So actually, I had a one video clip where recently the IoT has opened doors for new technology, which is called wearable technology. I hope so many of you are already wearing smartphones and then smartwatches, isn't it? So these are what the wearable technology. But the IoT has given a new paradigm to this IoT, so which is in terms of wearable technology. So now we in the market do have a skin like wearables which are called skin bandages. Skin bandages, simply you need to stick them on your skin and the job is done. It is going to read all the health related stuff. What is your temperature, what is your heart rate, and what is your blood pressure, and how much muscle you are stretching, what is your brain up to, and then what is your hydration level, and as well as that what are your feelings, how much stress you are having. So just imagine that you are all by yourself. It is just bringing your body understanding on your hand. So using this scan bandages can be helpful. As you can see that here we do have images. See here, you can simply read, stick it on to a toddler and you are going to read whatever it is feeling, because toddler is not going to express you much more in any language, right? So simply you have to understand that what is it is going through. So it's temperature, it's gastric problems or some other problems, you can make it out. And after that, just imagine that unfortunately you met with any unfortunate situation. Then who is going to tell about you to a doctor who is attending you at that particular time? So simply the doctor is going to scan it and then he is going to get all your vitals, your health records and your previous history. Based upon that, he or she is going to prescribe you the medicine. So imagine you are independent all by yourself. You don't need anybody now. Hmm? So again, it will be helpful in other domains where you can control the drones and other actuators by just hand gesture and as well as the eye gesture. So it is working according to your convenience. And again, it is said that it is free from cut and stitch. Simply it is embedding that skin bandage on the internal organs, and then the performance of the internal organs is evaluated and it is ready. So based upon that, the doctors are going to check on that how it is working. So if it is going offset, then they are going to recommend some of the operations or some of the medication to you. And the very interesting part is that now it is in the matchmaking as well. So simply you have to stick that on your skin, and if you are feeling the same frequency with the other person who is standing next to you, then it is going to blink you in a pink color. I don't know how much it is true or not, but it is there. Hmm? So just imagine that it is just going to bring that knowledge to you. So this is what the current phase of IoT. There is much more, but right now I feel that this is sufficient to know about the IoT, right? So with this, now we will be moving to the another interesting domain, that is deep neural network. So can you please cancel this? Go back to this one. So I assume that most of you are already aware of deep learning, deep neural networks, and most probably you people are working on deep learning platform, right? So with that understanding, we'll just start with the conventional diagram of deep neural network. As you know that this is simulating the human brain. It is consisting of multiple number of processing layers which are laid down between the input layer and then output layer. And each of the multi-processing layer is very much capable of extracting the hierarchical characteristics out of the input information you are providing. And that information is going to be used to make some decisions and then predictions. And then the classification is going to take place whether that thing is correct or wrong. Fine. So each of the multiprocessing layer is consisting of a neuron. This is a very core diagram of that neuron, which is going to consider the input information, and each of the input information is having certain weights or significance. And the job of the neuron is to perform the weighted sum computation along with some bias. Bias is used for adjustment of the weight, and then whatever the output is generated, that is fed to the activation layer. The name itself indicates that the activation layer job is to activate some of the neurons that which are bringing the promising characteristics for the prediction. Then we are going to get the output. Fine. So there are multiple number of neurons which are present in the deep neural network architectures. So now coming to the different architectures. So beforehand of that, I'm just going to give you one picture here. I hope so it is visible, right? Okay. Let's assume that I have a job to predict that whether a person is going to buy a premium or not. So to make this decision, I am having certain input parameters which are helping me to decide upon whether a person is going to buy premium or not. So here the input informations are age, education, income and savings. Now here, based upon these input informations, I am going to extract, I am going to derive some middle core information like awareness and affordability. Just be keen on it based upon the age and education, because see, the awareness comes with the maturity, right? That's why I feel that the weights, the significance of age and the education matters a lot in deriving the input parameter called awareness. That how much a person is aware about the premium, whether it is good to take or not, right? Now coming to the second parameter, that is affordability. Yes, of course, affordability is going to make sure based upon a person capability, whether he is able to buy the premium or not. He has to have some savings and income, right? Then and then only he is going to make the affordability, right? So here I can see that the course, middle course information are derived by the course information. And then I'm going to check that whether the awareness is more or affordability is more. Then I'm going to make a decision that whether a person is going to buy a premium or not. Okay, so I just request you to please keep this conventional diagram in your mind, because now we are going to explore some other architectures of the deep learning where you are going to see the same feed for neural network but Some customization is there here and there to satiate the underlying requirement. Okay. Now coming to the architectures, I have done some literature work where I have seen most of the applications which are being used in the market are making use of these many DL architectures. So I thought of providing you the elucidation of these many architectures. And the other reason is also there that I'm using some of the use cases in the further slides, and in those use cases I'm using one or the other deep learning. So whenever I'll be dealing with that use case, and if I'm using that RNN is used in the use case, then back of the mind you should be recalling that yes, this is what the architecture looked like and this is the reason, right? Okay, so that's why I have selected these many architectures. The first one is convolutional neural network. Second one is recurrent neural network. The third one is autoencoders, and the next one is generative adversarial network. And then we do have restricted Boltzmann machine, and finally we do have deep belief network. They are not limited. There are many DL architectures are there, but I have considered some of them based upon the use cases I'm going to refer. Now, coming to the first architecture, that is convolution neural network. This is my personal favorite. I have completed my PhD considering this CNN and then the customization of it. Okay, now see here, the convolution neural network is also a feed forward network. But the beauty of a convolution neural network is that here we are considering 2D image and voice signal as an input image. And this architecture is consisting of mainly three layers. The first one is convolution layer, the second one is pooling layer, and the third one is fully connected layer. What happens in the convolution layer is that the convolutional operation is going to be performed between the input image and kernels. In CNN, we do have three types of kernels. Kernels are nothing but they are the matrix of 3 by 3, 5 by 5 or 7 by 7. So it all depends that what is the size of your image. If suppose I have an image which is of 128 by 120, then preferably I am going to use 3 by 3 matrix. And if it is above that, it is around 256 by 256, then I am going to make use of 5 by 5 matrix, the kernel. And then if it is beyond that, it is 1000 by 1000, then probably I am going to make use of 7 by 7 matrix. So this you are going to decide based upon the input size. Fine. So the kernels are slide down through the entire image and they are going to perform a convolutional operation pixel by pixel, and then we are going to have the feature map. Feature map is going to be as an input to the pooling layer. Pooling layer job is to pull out the information from the feature map. So there are three ways. The first one is max pooling, second one is minimum pooling, and the third one is average pooling. In the max pooling, what exactly we are doing is that, let's say that 3 by 3 matrix we do have. So I'm just going to overview that which is the maximum value out of 9 pixels in the 3 by 3 matrix. So I'm going to grab, I'm going to pool that maximum information. So just imagine, out of 9 pixels, I have considered only one value which is going to be representative of that entire 3 by 3 matrix. Then there is a straight away rigorous reduction is there in the dimensionality. So the pooling layer is going to pull out the prominent information and then it is going to discard the unwanted information. This is what the maximum pooling. And in the minimum pooling, which is very rarely used, I am going to stick on to the minimum value and I am just going to discard the other pixel values. And coming to the average value, if you are very much keen towards grabbing all the information, then you have to go for average pooling, where I'm going to perform a weighted sum of all the 9 pixels divided by 9, and whatever average is going to come, that I'm going to consider as a representative of that entire 3 by 3 matrix. So this is very helpful. Either you are losing the maximum value or the minimum value. So you are going to consider the average of it. So in that way, we are going to consider the average value and then we are going to feed it to the fully connected layer. In the fully connected layer, we are going to stack all the output from the pooling layers. See, this is a vector in the fully connected layer. All the neurons are going to be in a stack form. Here, we are going to have a decision. See, I have a different input set and obviously I am going to end up with a different value. So I have to perform some normalization so that deep learning is going to understand, yes, this is what the value within which I need to predict the answer. So whenever I do have a non-normalized information, then my job is to normalize it so that to make a proper prediction. So in the fully connected layer, I am going to apply some activation function which are going to convert the random values to a normalized value. Generally, we technically use a logit as a word for non-normalized information, and we are going to apply the softmax activation function on fully connected layer, which is going to convert the logits to the probability value, which is lying between 0 and 1. So based upon this probability value, I am going to make a decision whether it is belongs to A class, B class or C class, like that. Okay. So I do have a one more layer here which is optional, dropout layer. Not all the neurons are bringing a promising information. So to maintain the balance in the neural network, I have to have some dropout, some optimization function. That's why I'm using dropout layer where I'm going to drop some of the neurons which are not that significant in making the prediction. So I'm using a dropout layer with a value 0.5 to 0.8. 0.5 means there are 50% chances I'm going to drop the neuron. Whereas 0.8 is representing 80% chances are there I'm going to drop the neuron. It all depends upon you that whether you are going for 50% or 80%, and that too with the understanding that how much balance I have to maintain in the neural network architecture. Okay, then I'm going to have a classification. Okay, so in either of the classification the result is going to fall. So this is convolution neural network, and mainly the applications which are yielding a heterogeneous information and as well as dimensionality problem is there, then I would suggest you to please make use of CNN. So these are the applications where we can find the usage of CNN, dimensionality reduction and heterogeneous information. Fine. Now coming to the next architecture, that is recurrent neural network. The word itself says that here we do have a recurring operation or a cycle is there. This is a feed forward network, but I do have a back propagation here. In the back propagation, I'm just going to feed the output of a hidden layer into a context layer. I'm going to store the output of each of the hidden layer in the context layer, which is acting as an extension to the input layer. See here, as you can see in the diagram, the output is stored in the context layer and again it is fed to the same hidden layer. So here I'm just relying on the feedback. What was the previous calculation? What is the current calculation? Is there any impact? Is there anything I need to learn because of the previous calculations? So this is helping with that. But having said that, I have just considered only one hidden layer and already the diagram looks so clumsy. And just imagine that if I keep on adding multiple number of processing layers or the hidden layers, then it will end up in becoming too complex, isn't it? So having said that, recurrent neural networks are inherently deficient in retaining the values which they learned over the period of the time. So the applications which are generating the time dependency value, which is very large, then the RNN is not sufficient enough. Why? Because RNN are having very short memory. For example, a fellow is asking me that what is the relationship between Ram and Sita after watching the mythological epic of Ramayana. So this is what RNN. They are not going to remember what they learned long back. So this is the disadvantage of RNN, and technically I can say that this is a problem of vanishing gradient descent. It means that there is no change in the weight. There is nothing to learn new about it. Whatever the output I am getting from the context layer, right? So that's why RNN is poorly going to face that vanishing gradient descent problem. So I do have an enhancement here for this problem of RNN in terms of long short-term memory, that is LSTM model. LSTM model are basically having a memory unit and gates. Memory unit is going to retain the arbitrary time or a previously learnt information over the long period of a time, and gate is going to make a decision that which one to retain, which one to discard, right? So it is like just RNN is there, and in parallel to that we do have a conveyor belt. So where the arbitrary information is available. So whenever RNN is being required, then it is just picking that memory, learning it, and then keeping back on the conveyor belt. So this is what LSTM arrangement. So whenever you do have a application which are generating the time series data, and as well as they do have time dependent information, then RNN and LSTM are adequate to use. So this is RNN. Now coming to the next architecture, that is autoencoder. Autoencoder is very famous unsupervised learning technique. Unsupervised means there are no supervisors, there are no teachers to tell you that what is this, what to do and what not to do, right? So the network has to learn with its own experience, and it has to extract the features from the input, and it has to learn about it, and then it is going to make a decision. Here we do have main two functions. The first one is encoding and the second one is decoding. Under the encoding, I am going to grab the input information and I am going to convert that into a one latent space code. Now look at here. The diagram says the number of neurons are same in the visible layer, that is input layer, and then the output layer. But look at that latent space, the coding part, only two neurons are there. So it means that the autoencoder is slashing down the dimension of the input rigorously. So this is very much used for the dimensional reduction application as well. So here I do have only two neurons in the latent space which are having the coding information of that input information. Now this input is fed to the decoder, and the job of the decoder is to reconstruct the original image by understanding the codes. Okay, so here we do have a character, and on that character we are going to apply the encoding, and it is converted into a latent space. It is going to represent that into a new delineation which is called latent space or codings, and that code is fed to the decoder, and the decoder is going to reconstruct or regenerate the input parameter, which is exactly same as that of the input information. So you can consider autoencoders in the applications where you do have a dimensionality reduction problem and as well as data compression. To compress the data, you can use autoencoders, and you can use them standalone, or else you can use them as an embedded architecture in any of the DL architecture. These are the autoencoders. Now coming to the next architecture, that is generative adversarial neural network. This is a hybrid model. Here we do have two neural networks. The first one is a generator and the second one is discriminator. The job of the generator is to synthesize the input. It is going to generate a synthesized or morphed input by considering some of the randomly selected input from the data set and with the additive noise, or it is selecting a noisy images from the input set, and then it is going to learn about it and it is going to mimic, it is going to generate a synthesized input, and that is fed to the discriminator, and the job of the discriminator is to discriminate which is real and which is fake. So as you can see that in this diagram we do have a gate connection in between the generator and then discriminator. In the first instance, I'm passing the real image and the discriminator is going to learn about it and it is going to be ready with the decision. And in the second instance, I'm going to feed a synthesized input which is generated by the generator, and then it is going to learn about it and going to be ready with the decision. Then the job of the discriminator is to discriminate which is synthesized and which is real. So over the period of a time, the generator is going to be so adept to generate real-time images which are very much difficult to differentiate which is real and which is fake. But it is throwing a challenge to the discriminator. It is making it to learn rigorously so that the discriminator is going to decide which is real and which is fake based upon the understanding, based upon the prominent features. I hope so. This we have seen in a multiple times, right? So the very good use case of generative adversarial network is to identify whether a 500 note is real or fake. So in most of the banking applications, you might have seen that a machine is there. Simply you have to insert a 500 note and then it is just going to emit. It is going to throw that if it is fake. So that is the job of the discriminator. Okay. So here it is going to understand the prominent features of the 500 note and then it is going to decide upon whether it is real or fake. Well, of course, we also know that what are the prominent features of that 500 note, whether it is real or fake, right? Okay, so this is a real-time application of GAN. And coming to the next one is restricted Boltzmann machine model. So here I do have only two layers. One is visible layer and another one is a hidden layer. And the restriction is that the visible layer and hidden layer neurons have to have a bipartite graph. It means that there is no possibility of having an intra-connection between the visible layer or the hidden layer. They have to have a connection between the visible layer neurons and hidden layer neurons only. So this is what the restriction in this Boltzmann machine architecture. Now the question comes into my mind that when there are no output, then how the model is going to learn that whether I'm bringing the correct answer or wrong answer. It means that there are no exams. Then how you are going to assess yourself whether I'm pass or fail, right? But I do have an answer for this. Here we do have a back pass and forward pass. So first of all, I'm going to consider the input which are coming from the input layer and then I'm going to multiply that with certain number of weights and then I'm going to add it with the bias value which is already present in the hidden value. So this is what forward passing. So I'm forwarding the input. Now the new output is generated on the hidden layer. Now whatever new output is generated on the hidden layer, it is going to send back to the visible layer with multiplication of same weights but adding with the bias which is there on the visible layer. Then of course I'm going to get a new output. Then I'm going to match with the newly generated output with the original input information, whether there is a match or not. This process I'm going to do until and unless I'm going to be in line with the input image and the newly generated output image. So it means that the model is rigorously learning about the patterns. What was the real image and what I'm generating. So quickly I just want to give a one class work to you people. You have to close your eyes and you have to draw whatever you have visualized so far. Dais is there, right? Podium is there and PPT is running. So you have to draw me this diagram. This is what your class work. So this is what RBM, right? So see here, so far you have visualized a scenario which is running in front of you and now the job is that to read straight or reconstruct that. Fine? Okay. Let me ace this class work. I'm just going to give you 5 chances. You have to chin up and look around, visualize it again and then you have to chin down and then draw it. And again in the second instance, you are going to look around and then again you are going to learn new things and then you are going to reframe it. Okay. And then see. by 4 or 5 chances if you are a good drawer, then of course you are going to get a real image. That is how exactly you are visualizing, right? It means that you are feeding whatever you are learning to a new layer, and then the processing happens. Again you are training your mind, again you are feeding that to your drawing. Okay, so in that way you are going to get, at least after 10 intervals, you are going to get a real image. So that is what deep belief network. In the deep belief network, I am going to have the number of stacks of RBM, restricted Boltzmann machine, where I am going to feed the output of one RBM to the next, and so on. Then I'm going to get a final output where I'm going to see that the reconstructed image is exactly same as of the fed input. Okay, so this is the belief network, because it believes that if a more number of trainings are provided, then the model is going to be accurate enough to making a good prediction. So these are some set of the deep learning architectures, and I hope so that now at least you are having a crisp knowledge at least about all the different architectures of the deep learning. So with this understanding, now we are going to get into another topic, that where we are going to understand that what are the different characteristics of IoT. See here, until and unless you are not having a clear idea with what information you are dealing, then how you are going to process it, how you are going to make sense out of it, right? So in case, see, for example, you all know Kannada language, right? Maybe Hindi, maybe Marathi, or maybe English. If suddenly I start talking in French, then how you people are going to understand? There is a concern, right? So you have to understand the interpretation out of a information which is provided to you. So first of all, we have to understand what are the characteristics of IoT and the role of DL in analyzing them in a systematic way, so that they are going to make the IoT devices more smarter. So the first character of IoT is time series data. Consider every IoT data. Every IoT is going to give you the information which is having the time boundation or time stamps. Take a temperature every seconds. Take a speed of the car at every hour, right? So IoT systems are generating the informations which are having the time boundation or time limitation or time stamp. Fine. So the current paradigm or conventional paradigm, whatever we do have in the market, they are not that adequate or suitable to handle the information, because it is continuously generating. So we have to have a robust model which is going to analyze some information out of it. So just now we have seen the LSTM and RNN, which are very much adequate to be used in the applications where you are having the time series data. So to handle the time series characteristic of a IoT, I would prefer using RNN and LSTM. Now coming to the second parameter, that is high noise. Consider any of the IoT device, they are generating the information which is having some additive noise. For example, RFID tags, radio frequency identification tags, which are used in the fast tag, right? Okay, they are also part of the IoT. When a sensor is reading the RFID tag, so maybe some other sensors are also reading, some other sensors are also generating the information. So there may be an inference and there may be a noise in terms of vibration of the machines or some other noisy signals. So to handle such information, I would prefer that you have to make use of the GAN architecture. Just now we have seen that the GAN is very much suitable for handling the noisy data. The discriminator is going to quickly decide upon that which is noisy and which is non-noisy. So better, whenever the IoT application is generating high noise information, then better you have to analyze it using a GAN architecture. And even you can make use of autoencoder as well, because it is going to slash down the unwanted information and it is going to grab only the promising information. Fine. Now, coming to the next one, weak semantics. What are semantics? Words with their meaningful information. This is semantic. Let me take an example. Let's say that I do have 27 and 77. If I'm going to feed these numbers to the any of the machine model, then they are not going to understand what is this 77, what is this 27. But if I'm going to provide a proper annotation to that, a meaningful information to that, that 27 degrees Celsius, 77 Fahrenheit, it is a type of the temperature, then the machine is going to interpret it in a proper way. So we are going to make use of NLP in the DL models. So to bring out the inference value out of the information which is available. Okay. So this is what the weak semantics. Now coming to the next one, massive real-time data. So just imagine that a flight which is having a flight time of 12 hours, and state of the art has stated that it is generating around 800 to 850 terabyte of information, that too in a dynamic time. So in such time stringent application, time stringent information, you have to have a robust DL which is going to rigorously analyze that what is happening in that duration, right? So you are going to make use of high technologies called fog computing and edge computing along with the DL to analyze that massive number of dynamic information. So you have to make use of DL. Better you can use convolution neural network, which is very much used in such applications, and as well as you can rely on the LSTM and then RBM. Fine. Now coming to the next one is large scale information, heterogeneity and then large scale information. Many number of sensors are there in the IoT system. Some sensors are there which are monitoring the ambience light. Some sensors are there which are measuring the moisture of the soil, which are sensing the temperature, which are sensing the light. So many sensors are there and all are producing a heterogeneous or variety of information. Then you have to have a system which is going to classify to their respective classes that yes, 27 degrees Celsius is the temperature. Okay. And if speed is there, that measurement has to be classified into the motion or speed, right? So that's why whenever you do have a heterogeneous information, with my personal experience, I'm telling that better to go use for CNN. So convolution neural network architectures are very much suitable for helping out analyzing the heterogeneous information, be it multimodal, okay, online, offline, with a different variety of data, file formatting, but the convolution neural network is very much suitable in handling that. Now coming to the next one, large scale data. So just imagine that enormous amount of sensors are there in the IoT systems and all are generating the massive information, and then the data models also have to be so rigorous, so adaptive to handle that information. It is stated that the DL models are also known as hungry models, hungry data models. So how much information you have, feed it, train it and get a better accuracy. Okay, large information is very much suitable for DL. They are hungry for data. So they are going to process however quantity it may be. They are going to process it. So these are some of the architectures, and when we do understand the architectures are like this, then which DL have to be used in that use case and how to analyze the data and come up with the answer. Fine. Okay, so with this understanding, now we are going to get into the limelight of this session, that is applications of deep learning in IoT. Right now in the market, we do have multiple number of applications of IoT which are categorized in these 6 verticals. Smart home is there, smart healthcare, smart grid, smart manufacturing, smart agriculture and smart transportation. and the role of the DL is going to define the use cases which you can see in the horizontal way in each of the vertical. So what is smart home? It is an imperative applications of IoT. Many number of appliances you do have at home, right? And nowadays at least they are smart enough to understand how is my resident. So they are just starving high to provide a comfortable and cozy environment to resident. You don't need to train them. They are made for that. They are rendering the service for which they built for. Okay. So they are just going to learn the pattern of residents, that how much temperature they want, and when to switch on the light, when to turn off the light, when to turn on the ACs. They know everything. They're just learning the pattern of the resident, and based upon that they are being adaptable to that. Okay, so they are just rendering the services according to the convenience of residents. And here, if you are going to have a DL, then definitely you are going to enhance the smartness of home appliances. Like, first we do have a energy demand prediction. Second one, we do have behavior monitoring. Next, human activity recognition, and then the posture detection. These are some of the use cases which fall under this smart home. So can you click on this smart energy demand prediction? Under the energy demand prediction, first of all, I have to predict that what is the demand of the energy consumption. What is energy? Electricity. When I'm using multiple number of home appliances, then every home appliance is consuming some amount of energy, right? Based upon that, I'm going to predict that what will be the probable consumption of electricity. If any of the appliances is under the fault working, but still it is consuming more energy, then that information is brought to the resident so that he or she can make some alternative arrangements, and then they can take some precautionary actions. So the energy prediction system has to be there at home, so that we will be knowing that how much we are consuming and what is being given to us. Okay, whether we are going to the maximum use or we are using it at the minimum point. Okay. So this is what the diagram where we can see that there is a blend, mixture of IoT and deep learning. So IoT is gathering all the information about what all appliances are there, how much energy they are consuming, and that raw data is fed as an input to the DL where the processing happens. Because heterogeneous information is there, we have to bring it in a normal way. Normalization is there, and on an average, what is the difference between the consumption? That is moving average. And then I have to predict the missing value. Okay, what was day before yesterday and what is current. Okay, so that value I'm going to analyze, and then I'm going to feed this processed information to the LSTM model. LSTM model is going to rely on a historical value. What was the consumption on so and so date and what was the consumption today? Based upon this, they are going to bring out the information. And this difference I am going to measure using the parameters called root mean square error and mean square error. Okay, so they are just going to bring out the difference between what was observed and what is expected. Fine. So this is what the application of energy demand. Now, coming to the next slide, go back to the previous slide. Behavior monitoring. So I'm revealing all the slides. So this is a one use case where I can see that I want to keenly observe the behavior of a player who is going to hit a winning shot. So what I'm using here, I'm using Raspberry Pi high quality camera video. And then I'm going to grab the video clips and as well as still images. And then I'm going to feed that to the image processing to process the image in terms of enhancing the contrast, brightness, or some other parameters. And then that is fed to the human detection and segmentation. The contour information of a human figure is extracted, segmented, and then that is fed to the feature extraction. where I'm going to extract the hand lift portion, the projection, the angle of the back lift, like that. Okay, so these many parameters are extracted and I'm going to label them. I'm going to represent them with a categorical value. Okay, if my position is like this, then it is 0. If my position is like this, it is 1, like that. I'm going to represent the categorical value to that. And then I'm going to prepare a training set which is going to given to the DL recurrent neural network. It is going to analyze that what was the behavior at that particular time, and it is ready with the decision. Then next in the testing phase, again I am going to grab a video clip from the Raspberry Pi high quality camera. The reason I am using this because it is having a very good frame numbers which are taken within seconds, because video clips are there, so many movements are there, right? And that too dynamic. So I have to grab all the behavior of a player, and then I'm going to detect the pattern, and then I'm going to filter out of the redundant information, and then I'm going to have a match. So here I'm going to analyze, is this the same position, is this the same behavior of that player which has given him the winning shot. So I'm just going to come up with the information that yes, this is a behavior. Then I'm going to take it for my reference to enhance my play. Okay, so this is a behavior monitor. Now coming to the next one, a posture detection under a smart home, and as well as a facility, or you can consider in the healthcare system as well. Now look at here how I'm sleeping on the bed. Based upon that, the posture is detected and the alert message is given to me whether it is correct or not. Okay, to tell you in a detailed way, the authors have created a e-mattress, which is consisting of piezo-resistive sensors, which are very much responsible for reading the pressure of a human body. Based upon that, they are going to generate a categorical heat map images, and this is fed to the convolution neural network, and the convolution neural network is very much known for multi-class classification. I do have 6 classifications based upon the posture. First of all, if a categorical heat map image is going to be blank, then it says that there is no person, there is no occupancy, so it is categorized to the unoccupied. Next one is face up. The heat image is different based upon the pressure which is generated on the E mattress. Okay, because here it is equally distributed and you can see the posture of the exact human skeleton, isn't it? So it is going to generate the heat map according to that. Now coming to the next one, face down, and then face lateral to the right, to the left, and then on the edge. This is very crucial. The E mattress is specifically developed to identify what are the chances that the person is going to fall off from the bed. So you can have this application at your home to visualize, to have a vigilance on your toddler who is sleeping on the bed, and the senior citizens as well. Okay, so what are the chances that the person is going to fall off from the bed? As soon as the categorical heat map is going to generate a pressure on the edges, it is going to generate a message to the patient, caregiver, or the doctor. Based upon that, they can take some precautionary actions. So this is the posture detection which falls under the smart home. Now coming to the smart healthcare vertical. I don't think so that I need to tell you much more about the healthcare. We have seen a video in the first slide itself where you can see the skin bandage. It is going to bring your understanding of the body to you, and based upon that you can make the necessary arrangements and you can take some precautions. Okay, I hope so that nowadays at least you might have heard many number of news where people are come to death for heart attacks at the young age, right? So to tackle with this, the United California London School of Medical Science, they have come up with a vest which is reusable. That vest is consisting of 256 electrical signal sensors. They are just going to put that vest on your body, and then they are going to understand the electrical wave, the reason why our heart is beating. If they observe that if any offset value is there in the electrical waves which are generated, then they are immediately going to alert you that kindly please visit your doctor. And based upon that, they are going to give you some medication. And along with this, they are going to add this with the MRI of heart, and 3D image model is generated, and as well as the electrical pulses are generated. Based upon that, the doctor is going to prescribe you that what to do and what not to do to improve the heart health. And I hope so that you might have seen the diabetic patients at your home, right? So continuous vigilance has to be there on the diabetic patients. Nowadays, at least if you have seen that a disc-like sensor is there, CGM, continuous glucose monitoring device is there, which is clipped on the skin. It is going to penetrate in your skin, and it is going to read the content of the glucose in the fluid, and what you are eating, when it is escalating and when it is getting down. So based upon that, the doctor is changing your diet chart, and as well as they are going to give you some other medication. So CGM, that is also a smart device which falls under the healthcare. Okay. Now coming to the next one is smart grid. Smart grid, actually here always we have to have a balance between how much energy is provided and how much we are consuming. So there has to be equal balance. We do have a smart grids which are deciding upon that what are the resources available, who are generating the energy, and what are the consumers, how much they are consuming. So based upon that, the smart grid is analyzing how much I need to be prepared, so to satiate the requirement of the consumers. Okay, so here we are using LSTM model, and LSTM model is very much helpful in giving an analysis of the historical value and then the present value. If the demand is increased, then of course the smart grid has to increase the supply as well. Okay, so I will just deal only one use case under the smart grid, and then we are going to get into this smart traffic management or the smart manufacturing. So many companies are there which are manufacturing the product, and you do have a different segments in the manufacturing. So under the manufacturing, the blue collared workers are significantly monitored in the manufacturing companies, that what is the productivity of those workers, how much they are working. If you are having a daily wages workers, then you are releasing their wages based upon the amount of work they are doing in the entire day. So you have to rigorously monitor the work, the amount of work they are doing. See, sometimes supervisors are also compromised. They are just going to generate a fake information. So better to rely on the IoT and DLL. Okay, so out of all these use cases, I'm just going to handle only one use case, that is worker activity recognition. So I know that it is a bit weird use case I have selected, but I feel that you will feel relatable to this. This is meat processing plant. The job of the production line workers is to get a meat portion and then cut it into pieces and then prepare the boxes, and then their job is done. But see here, in this tenure, so many jobs they are going to perform. So here, first of all, I'm just making them to wear the watches, wrist watches, in which the proximity sensors are there. Proximity sensors, which are going to detect the object which is coming in front of them. And then they do have a proximity sensors, accelerometers are there, and then gyro sensors are there. As you can see that here, workers are standing. These are the workers. And as you can see that here, a box is there, which is a Raspberry Pi box which is going to gather all the information which is coming from the sensors which the workers are using. And workers are standing in front of the conveyor belt on which the meat is kept. Okay, whenever the meat is coming near to a worker, it is giving him a alert message based upon the proximity sensor that the object is detected in front of you. And now the work, the activity of the worker is being monitored, whether he is going to pick this or he is just going to sit idle. Okay, so here we do have certain classes which are given here. The position of weighting the meat is like this. Okay, see here he is using smart knife, and in the smart knife also there are certain sensors which are evaluating the pressure. And if a person is standing idle, then the pressure is 0. Okay, and look at the projection of the knife. It is vertical. He is standing like this and he is in a idle position. So I am going to categorize this activity as 0. Why? Because the person is waiting for the meat. Second one, knife sharpening. See here, the amount of pressure I am using to slice down, it is going to give me the indication that whether I am putting more pressure on it, then of course it gives me an indication that you are putting more pressure beyond the threshold value, so better you have to sharpen your knife. Then he is going to spend some amount of time in sharpening. Now look at the projection of the knife. He has to hold it in a horizontal way and then he has to sharpen. Okay, that projection is also monitored, that how he is sharpening that. And after that we do have working on the meat. Now see here, he is just holding his right hand like this and he is just going to feel the meat. He's just going to check that how much fat is available on the meat. He's just going to serve his left hand on the meat. And based upon the understanding, he's just going to use a knife to slice it down. And then he's just going to rip the skin out of the meat. Now look at here, on both the hands, the proximity sensors are there which are measuring the pressure he is applying on that. Okay, now based upon that, that weight is also recorded. Okay, and look at the action. And now the projection of knife is in the horizontal direction. Now, even this is also going to give an indication that how much a person is experienced. Because here, if you are going to put too much time on feeling the fat area, then you are not at all experienced. Because when you are working on that particular thing on whole day, then of course you do have a sense that how much fat is there, where it is there, and how to rip it off. Okay, so based upon this, it is going to bring you the understanding that how much experience that worker is. Okay, and after that, ripping the skin out of that chunk, I'm going to cut it in the slices, which are very much suitable for package sizes. And then a certain pressure I'm going to apply on cutting the pieces. Okay, and even the pressure, the projection of the knife is recorded there. Okay, and then I'm just going to put it back to the conveyor belt and then it is going to the packaging. Okay, so this is what the number of activities are being monitored and all these sensor informations are fed to the Raspberry Pi using a Bluetooth technology and then it is gone to the monitor. Okay, there they are going to analyze that how much pressure the worker is applied on cutting the slices and then making it chunks and then ripping off the skin and so and so. So based upon this, they are just going to come up with the KPI, key performance index, which is mainly depending upon the number of meat pieces he is going to process in a day and how many time he has spent in just sharpening the knife and then the knife sharpness. Why? Because if the knife is sharpened, then of course he is going to put less time in cutting the pieces. Okay, so based upon this, the employee is going to observe that how much work he has done in a day and then how much wage is to be released to that person. Okay, and this is what the performance monitoring under the manufacturing companies. Now coming to the next one is smart traffic. Okay, let's deal with this only. I hope so in many times you have seen this picture whenever you are traveling on the highway and you are passing by the tolls, then probably you might have observed this. Okay, and whenever you are entering into a city by the highway, then also you have monitored some of the pictures. Okay, where IR sensors are there, proximity sensors are there, accelerometer and gyro sensors are there. IR sensors are going to observe the infrared images of a number of vehicles. Even they are capable enough to capture the information at night as well. The light is not visible to the human eye, but they are capable enough to capture the image in the night as well. Now, the accelerometer, I think you might have seen that how much accelerating you are doing the car. It is going to show on the board that your speed of the car is this much. If the speed limit is 40, then it is fine. If it is beyond that, then the challan is ready, isn't it? So these are the pictures which are going to helpful in monitoring the information, and again they can predict the information that what will be the predictable traffic in the nearby areas by counting the number of cars on the highway. And even in the traffic signal also, these kind of sensors are playing a very vital role. They're just going to set a limitation of the time. If they see that the number of vehicles are standing more on a particular lane, then the traffic time is more to that lane as compared to the others. Okay, so these are some of the sensors which are used in the traffic management system. And coming to the smart parking use case, here you can see that in malls and in some of the big IT industries, they are using smart parking. As soon as you enter into the basement parking, a gateway board is displaying that how many number of cars are already parked and which all slots are available. So based upon this, you can go through that lane and then park your car there. Again, the proximity sensor, the object detection sensors are laid on the floor or else they are on the side bars. They are identifying the object, and that too based upon the height. If suppose the space is occupied, then it means that around 10 to 15 centimeter they are going to send a signal to verify that is there any availability of the object in that area. If they are going to sense the presence of any object, then they are going to say that yes, the space is occupied, the car is already parked. And if they are not going to sense any object beyond that, then it is going to come up with the information that the space is free. And if some objects are already there which are below 10 centimeter of that sensor, then it is going to indicate that some dirt is there and it is overlaying on me, so please clean it. So these are the three signals you are getting out of the proximity sensors which are laid on the parking slot. And you will be coming to know that how many slots are free and how many slots are empty. Based upon that, you can park your car. Okay, so these are some of the okay use cases, and even you can see that here we can use it in a smart agriculture also. Okay, I'll just deal with two more use cases and then I'll get into the main use case, that is human activity recognition. Now here, first of all, my job is to identify what is the disease of tomato plant. Okay, what are the different diseases are there? So first of all, I'm just going to grab the input information, the images, using the Raspberry Pi high quality camera, and that is embedded on the NVIDIA Jetson Nano GPU processor, which is going to embed the artificial intelligence network on its board, okay, such as AlexNet. AlexNet is a pioneer of convolution neural network, which is consisting of 8 number of layers. 5 layers are made up of CNN and 3 layers are fully connected. First of all, the images are captured from the different diseases of the tomato, and then they are fed to the AlexNet and the model is trained and the model is saved, and in the next instance, whenever I'm capturing the data in the real time, then the testing happens with the matching ability of the input information which are already present in the LXNet. So here you can see that the test result is yielding the early blight, that infamously called bull eye disease in the tomato plant. So the AlexNet is already trained by this kind of images, and based upon the test image it is going to see that which kind of disease it is, and then it is bringing a good match between the leaves images, and then it is going to give you the answer. So this is a one use case where we can see that we can increase the classification or the understanding we are bringing to the farmers, that what kind of disease it is, so that he or she can take some necessary precautions, that what pesticides should be used to handle such kind of diseases. Fine. Now so this is a generalized architecture which is generally used in the smart agriculture. So whatever data you have regarding the crop yielding, you have to collect it. Maybe it is soil moisture, maybe it is temperature, maybe it is humid, and maybe it is quality of the soil and the resource availability, the water, the pesticides. So the sensors are bringing the information, and then that information is processed by means of some image processing techniques, and then that is given to the models to get trained about it, and then we are going to provide a test image, and based upon that they are going to come up with the information. So this is a very generalized architecture which you can consider for the other use cases of the smart agriculture. Okay, now this is very interesting. This is called weed boat. Now, if you see that nowadays at least we are having a scarcity of workers. Workers are not easily coming to your field and then they are helping you out with removing the weeds, right? So better to use a standalone device called weed boat. So it is consisting of laser, camera, and it is going to provide you the information that which is crop and which is weed. So based upon that, it is giving some signals to the laser, it is turning on, and then it started killing the weeds which are present in the crop. So how it works? Actually, this is a standalone device which is made to run on the crop field, and first of all, it is capturing the images, real-time images. Those images are fed to the AI supercomputer. This is the smallest AI supercomputer in which we do have a computer vision and as well as the object detection model, that is YOLO version 5. First of all, the YOLO is already trained by providing some weed images and as well as crop images, and it is ready with the object detection capability. Okay, so whatever real-time image I have captured, that is fed to the AI supercomputer, and it is going to detect the objects which are present on the crop field, and then it is going to send that image to the computer vision, where I am going to make use of convolution neural network, which is having a adequate architecture to classify which is weed and which is crop. And then the signal is sent to the actuator, that is a laser. It is turning on and then it starts killing the weed. So this is, I think, a very smart weed board, and it is finishing its job. I think I heard that. I don't know that how much it is true. So it is taking half an hour time to complete 10 acres of land, it seems. So the state of the art states that, so that much fast it is. So you can assume that how smart the devices have become now. And using this, of course, we can enhance the crop yielding, isn't it? That too with no wastage of time and then resources. Now I'm coming to the last part, that is the case study of human activity recognition. Okay. Well, human is going to perform the different activities in a span of certain seconds. Okay. Now you see that, and I'm watching on you, that many people are performing different activities. Some people are talking on phone, some people are yawning, some people are stretching their muscle, like that. So there are different activities, right? Okay, then what knowledge you are rendering to me by just yawning? That are you bored? So this is what understanding, right? So many number of applications are there in the market where the human activity matters a lot, based upon which we are going to gather some valuable inferences that what this activity is up to. For example, in the prisoner, looking at the behavior, monitoring the activity of a human, we can analyze that what that human is up to. And even such kind of applications are used in the monitoring of COVID-19 patients back in the time. That what is the behavior, what are the different activities, the patient who is having COVID-19, what are the behavior, what activities he is capable to do. Okay, so based upon that they can come up with some conclusions. So here what we have done is that first of all we have gathered the input images from wisdom data set, wireless sensor data mining laboratory. This is a data set which is consisting of 10 lakh rows, about 6 activities of a human. You can consider the data set, you can make use of the data set based upon the underlying problem. You can make use of 6 activities, you can make use of 10 activities. There are so many number of activities which are already recorded. So here in this architecture, first of all, we have used the wisdom data set where we have seen the different activities of a human, and it is consisting of 6 columns, and altogether it is consisting of 10 lakh rows. 51 subjects we have selected, and we just ask them to perform 18 activities for 3 minutes. If you are sitting, this is the first activity, then you have to sit for 3 minutes. If you are running, then you have to run for 3 minutes. So like this, the subject is made to perform 18 different activities for 3 minutes. And then we have closely monitored that what is the behavior, what are the activities in running at least. Okay, now see here, the position of the running is continuously like this, right? So the changes are there, acceleration is there, and gyroscope sensors are also used. So what we have done is that we just made them to wear their smartwatch and as well as keep their smartphones in their pockets, and then they asked to do the 18 different activities for 3 minutes. And based upon this we have recorded the activities. See here, what we have done is that if I asked a person to walk, okay, while walking the person stands for at least a fraction of the second, then also we have not recorded that. Why? Because that is falling in the other category. That's why rigorously we have been monitored that the person is in action, the said action, for 3 minutes. Okay, like that we have collected information, and then all these informations are of course in timestamp, that within 3 minutes how he is sitting, in what posture he is sitting. Again there are so many varieties how we sit, right? So that are also divided, that are also considered. So here first of all we have considered the data set, and we have splitted it into two parts, 80 and 20%. 80 is training and 20 is testing. And then we have trained our LSTM model, and then we end up in having the activity recognition model. And this activity recognition model is going to consider the 6 parameters: user ID, timestamp, accelerometer value in x-axis, y-axis, z-axis, and then activity. So these 6 columns information we have extracted from the human activity, and by training those activities using the LSTM, we are coming up with the output that what that activity actually. The model is already trained with the 18 activities for 3 minutes of 51 subjects. So whenever you are providing a testing video clip or a still image, it is just going through with that model and it is bringing you the output, that what kind of activity it is. So based upon this, whatever problem I'm using this data, so you are going to get an information. If I see that the person is continuously sitting and then walking here and there, then I can visualize, I can sense that the person is having a low confidence and he's just going to do something which he is not agree in sense. Right? Okay. So see, sometimes I get overemphasized. Sometimes I get nervous. Whenever I get nervous, I start sweating and then I just walk here and there. Isn't it? Just to cool down my temper. So that activity also plays a very important role to understand what human is up to. Okay. So these are what the use cases I just wanted to discuss and bring it to you. And I hope so that somehow you have understood that what is the role and the potential of having the deep neural networks in the IoT and making IoT devices more smarter and smarter. I hope so. I'm on time, and now it's better to have a discussion and accept some questions if you do have. Yes. Yes, my dear students, how's the session? Hmm? Have you got any information? Or was I too fast? Content was more, then of course here and there I rushed. Yes, I hope so. At least you got the definition of DL, the different architectures, and some use cases, right? Okay, done. Yes, faculty members, any question, any concern, anything you would like to discuss rather than saying question answers you want to discuss. If you are working in deep learning, uh, I have provided my information. Actually, I am into some real-time projects. So if you want to have a collaboration, then you can connect to me. Or if you are pursuing your PhD in deep learning and IoT, then also you can feel free to connect to me. Yes, done. Or if you want to go back to any of the slides, then also let me know that I can go back to that and then you can have. No questions? I don't think so that whether I'm relatable to the topic or not. Yes, sir. Done. Okay, then thank you so much for providing such a nice platform. I really felt very privileged to be here and to be part of prestigious ATAL. Uh, because we know that in the academic ATAL FDP matters a lot. I always struggle to be a participant in that, but with the grace of God, I got the opportunity of being speaker. So it is a great thing to me, and I'm very thankful to the very respectful Golgi sir. Thank you so much.
Thank you, ma'am, for sharing your knowledge. We appreciate all the valuable insights you have provided.
Now I would like to request Shilpa ma'am to present the memento to our today's resource person, Dr. Vani Hiremani. Thank you, ma'am.
I request everyone to follow for a small break. We shall be back by 10 minutes.